blame yourself. So this is a cube. Well, we want to find the surface area of this cube. Surface area of this cube. Well, we need to know what area is first. This is a cube. We unfold it. We can see that 6 of the same shape, which is 6 squares, made this one cube. Alright, then let's pull out one rectangle. Pull out one rectangle. Where's the pen? Pull out one rectangle. Simply look at this one rectangle. Alright, let's say this is 1 centimeter. So big. This is so big. Alright, so let's say 1 centimeter, and this is 1 centimeter width. What is the formula to calculate the area of a rectangle? Area of a rectangle is length times width, or you can say base times height, which equals 1 times 1. Which equals 1 centimeter. Remember to use squared. Remember to use squared. How do you remember square? Oh, it's a pretty easy question. So let's say we're saying A equals base times height. Area equals base times height, which equals 1 times 1. The dot means 1, remember, which will equal 1 centimeter squared. How to remember the centimeter squared? Look up here. What is 1 times 1? That means 1 centimeter times 1 centimeter. So imagine there's also 1 times the letter centimeter. 1 times the letter centimeter. So 1 times centimeter plus times 1 times centimeter. So if we would have been multiplying that, here's a fun part. We group down 1 times 1 times centimeter times centimeter, which is a pretty weird strat. The forward, the first bracket results in a 1. The second bracket results in centimeter times centimeter, which is centimeter squared. See? Centimeter squared. Get it now? Square basically just means something multiplied by itself. Alright. We calculated 1 square. That ain't it. It's not it. We have 1, 2, 3, 4, 5 more left. If we would have been moving this square back, would have been fit perfectly, which means the 6 are congruent. So calculating 1 square basically means calculating all of the areas. Why? They're all the same. Ask me why they're all the same. It's a square, but it's a square. How are you going to fold a square if you don't have 6 congruent quadrilateral? Don't believe me? Try yourself. Okay. So area for 1 square is 1 centimeter squared. We want to find the area of everything, which is the surface area, the outside, the outmost layer of a 3D shape. In this case, a cube. Or a rectangular prism, you might argue. So we found 1, which is 1 centimeter squared. There it goes. Algebra. 1 centimeter squared. That is 1 centimeter squared. That is for 1. That means this is also 1 centimeter squared, resulting in this is 1 centimeter squared. 1 centimeter squared, 1 centimeter squared, 1 centimeter squared. See that? Because all of them are congruent. So congruent means their sides are the same. That means the two sides multiplied. So the product of the two sides must all be the same. 1 centimeter square, 1 centimeter square. So there are 6 squares in total. So 1 centimeter, 1 times 6 equals 6. So the surface area of this cube with, it's called vertices of 6. No, vertices of 1 centimeter. What am I talking about? Vertices of 1 centimeter is 6 centimeters squared. Always remember the unit, or else you get a 0. I'm kidding, you might not get a 0, but you will just lose some mark. You understand what I'm talking about. Alright. Let's remove whatever's there. We folded them, we then folded back into a square. I mean a cube. What am I talking about? We fold it back into a cube. This is a, pretty nice cube. The lightings are pretty cool. So we can see that the surface area is 6 centimeters squared. 6 centimeters squared. Alright. See this cube? You might ask, so we're done. What else are we gonna do with it? Volumes. So basically volume means we don't care either it's filled or empty in the middle. We'll just say how much space it take up. How much space it take up. Like we don't care if it's filled with candy, Skittles, M&Ms, iron, wood. I don't care. So it's just what it matters is just how much space it takes. Whatever fills inside changes its mass, not its volume. Let's now calculate the volume. Alright, listen up. Imagine this squared. We have 2 squares stacked on top of terrible stack. Alright, let's not use that. Let's use a different square. So imagine we have like 8 squares stacking top of each other. Let's start with simple shapes. Imagine we have 4 squares aligned like this. How are we going to calculate what's the area if we know that this is 1 centimeter and this is also 1 centimeter? Area of the total shape. Well, that is pretty obvious. We'll know that this is also 1 centimeter. That is also 1 centimeter. And then we multiply the base and the height, or the length and the width, you might say. So area will equal length multiplied by width, or base multiplied by height. That is the formula. And then we continue calculating with substituting the values, which equals 1 times 1, 2 times 2, since the square is 2 rows of 2, which will then equal 4. Always remember units. That is pretty much it for a square. Alright, so what does the 2 times 2 mean? 2 rows of 2. Alright, what if we add in one more dimension? Alright, we get this here. We pull here. Now we're gonna do some art. Whoa, what a big shape, huh? Oh man. Let's just... well, I'm not gonna say it's trash, but it's still useful. Let's just say we're gonna make the smaller version of that huge net, and then we're gonna say this is 2 centimeter. 2 centimeter. Pretty bad with my mouse. And all the rest of the edges are 2 centimeters. Now we fold it. Now we made a square. We know that one vertex will be 2 centimeter. One vertex will be 2 centimeter. The rest will also be 2 centimeter. Now imagine dividing lines. Which divides the square into 1, 2, 3, 4, 5, 6, 7, 8 cubes. 8 cubes. Listen up. So, if we had 4 like we had before, it'll be 1, 2, 3, 4, 4 squares because it's 2 rows of 2. Now we are in a 3D shape. We have one more measurement, which is the height. So now we have 2 levels of that flat pad, I'd say. So now what we should do is we would obviously be able to imagine volume is length times width times height. Should be easy to imagine. Which will be 2 times 2 times 2. Also, bracket touching each other also means multiplication. Now it's going to be 4 times 2. Now it's going to be 8 centimeters squared. No, centimeter cubed. Why? Why? Imagine there's a centimeter here, centimeter here, centimeter here, and then we take the values, which is an 8, we multiply them, which is 8, and then there's a centimeter right behind them, we also multiply the centimeters, so there's 3 centimeter, which is centimeter multiplied by itself 3 times, so it's 8 centimeter cubed. Look, we're also measuring cubes, not creepers, not breads. Alright. So that is basically how you calculate volume and surface area. That is the simplest version. You might ask, well, I only learned squares. What if my mom asked me to calculate the surface area of a rectangular prism or triangular prism or anything? Don't worry. Surface area of any prism, like literally any shape, it's literally all their exposed surface combined. For example, we'd have a rectangle, and then we'd have 3 rectangle, we'd have 4 rectangle, and then we make it into a rectangular prism, looking pretty nice. And then we'd say this is 2 centimeter, 1 centimeter, 1 centimeter, 1 centimeter here, 2 centimeter here. Unit is centimeter. do it? Okay, chill. Okay, chill. I'll help you do it. The surface area, like of any shape, it's basically all of their faces combined. So we take out one distinct shape. Since we measured it, it's 2 and 1. We'd calculate the area by going area of a rectangle equals base times height, which then equals 2 times 1, which then equals 2 centimeters squared. Sure. Centimeters squared. Oh, that is 1. Well, it's not as easy as squares. I'm not done right now. That is 1. See that? 1, 2, 3, 4. Calculated 4 areas, but we did not calculate the squares yet. Since we said squares is 1 by 1, then the area of this one square would be 1 times 1 would be 1 centimeter squared. We calculate the 2 more shapes, then we can add the shapes, we can add all the surface areas up. Now it's going to be, let's give them a name. Let's give them a name. Area A1, area A2, area A3, area A4. Why do I name them starting with A? They're all the same shape. They will have the same area. What about the 2 squares? We'll name this square B1 and B2. Just can't get a center. B1 and B2, since the 2 B's are congruent, they have the same area. Now we sum it all up. It's basically A1 plus A2 plus A3 plus A4 plus B1 plus B2. What does that equal? It equals 4A1, because all the 4 A's are the same, so we just need to take 1, multiply by 4, plus 2B2, same reason, the 2 squares are the same. So it equals 4 times 2 plus 2 times 1, basically equals A plus 2 equals 10 centimeter squares. Oops. Centimeters squared. Now you're not afraid of anything. You are not. You can literally find any sort of shape and then you can calculate its surface area. I trust you. How about the volume? The volume? We don't need those labels no more. You know, this is 1, this is 2. We fold net. This is still 2, this is still 1. The height is also 1. According to our formula, we just go length times width times height. Volume equals. Which means 2 times 1 times 1, which equals 2 centimeter cubed. Centimeter cubed. Remember, it's cubed. Alright, this is how we basically calculate the surface area and volume for rectangular prism and square base prism. That's not how you say it. Rectangular prism, square base prism is also a type of rectangular prism. Alright, so thanks for watching my video. If you like my video, please subscribe and have a nice rest of the day, and bye.